Now you can see find host for VM is the main function which need to be edited, or you can just place your own code to place virtual machines to the appropriate host or physical machine. Remember that no need to change on these lines, just go for the or entire body of the function. Keep in mind that you will return allocated host as a variable. It means you have to assign your outcome to this variable allocated host. The type of allocated host is power host. Power host is some class file in CloudSim. I will run this lrmmt.java. As you can see in the description, a simulation of heterogeneous power-aware data center that applies the local regression for VM allocation policy and minimum migration time for VM selection policy. So remember, for dynamic consolidation of virtual machine, we have one VM allocation policy and minimum migration time policy. And last one is virtual machine placement policy. So if you are designing your own virtual machine placement policy, what you will do, you will just put your code here. What is our VM allocation policy? We are using local regression and MMT. Based upon simulation result, it has been found that LRMMT, local regression for VM allocation policy, and minimum migration time for VM selection policy has been found suitable. Now I will run this LRMMT. Among all these methods, LRMMT provide best outcomes. Now I will run this file. Just put right click over there and run this file. This is the output given by the simulator. You can edit the code of CloudSim to remove unnecessary lines. If you will remove all these lines, you will get direct your output. It will save your time. I will explain the entire structure of this out. Just wait for a few seconds. You can see this code is running. Now you can see the output. Within 52 seconds, you got the output. Look, the first line, initializing, starting, LRMMT 1.2. What is 1.2? This is the scaling factor. This scaling factor is used in VM allocation policy. You can see here 20110303. This is the file, data file actually. Please see the LRMMT code. We are calling here workload of 3rd March 2011. This is the planet lab. You can change the dates. You have 10 dates in the workload. Whatever date you will write, the output will be changed as per the workload. You can see here VM allocation policy, that is LR. LR means local regression. This is the policy to detect overloaded hosts to predict the utilization. This VM allocation policy is used for these purposes to predict the utilization and to detect the overloaded host. VM allocation policy, MMT, minimum migration time, and scaling factor 1.2. This is the structure. This is the plain structure of lrmmt.java. Now see the output. Now simulation has been started. Here you can see trying to create VM0 in data center, and as soon as you will scroll down, you will find that just scroll down, you can see there are a lot of virtual machines. According to the workload, these are 1051. Total number of virtual machines are 1051. As it starts from 0, so total number of virtual machines are 1052. Because ID will start from 0. Now VM0 has been created in data center 3 host 1. VM0 has been created in host 1. Initially, simulation allocate virtual machine as per the default policy. VM1 has been allocated to host 3, and you can see that there are 1800 hosts. You can change the number after changing the simulation code. Now, total number of virtual machines 1052 has been created. Some certain number of hosts. There are 800 hosts has been simulated in this cloud. I can show the file, that is Planet Lab constant. As you can see, this Planet Lab constant file, number of hosts has been initialized or declared 1800. You can change here. You can make it 100, 500, whatever. Now see the output. Now sending cloudlet. Cloudlet means cloud application. Cloudlet 0 to VM0. This power package. If we have 1052 virtual machines, 1052 cloudlet has been assigned for 1052 virtual machines. There are total number of 1052 cloudlet for 1052 virtual machines. Now these are the outcomes in the mid of simulation, and this is the final outcome. You can see here 80126 seconds. This is the, as you can see, this is the workload of 1 day, 24-hour workload. Simulation has been designed as per the workload. You can see the experiment name is as per the workload. Number of host 800, number of virtual machine 1052 as per the host. Total simulation time 86,400 seconds. It means 1 day, total 1 day. Energy consumption is 163.15 kilowatt hour. To run this workload as per these policies,